Okay, so today we're looking at, get started. We're starting our 1.3 notes. This section is over solving simple equations. Okay, so part of solving these is knowing the underline these, please. The addition property, the subtraction property, the multiplication property, and the division property of equality. Now, what this is talking about is, and you've done this before, like part of whenever we work with algebra, we have this equal sign. So that equal sign keeps it in balance, okay? It is like the middle if we had a scale, okay? If we had a balanced scale like this, the equal sign is in that middle. So if we want to keep it balanced, whatever we do to one side, we also have to do to the other side. Okay, so if I have a 3 over here and a 3 over here, right now it's balanced because there's 3 on each side. Yeah. But if I were to add 2 to this side, now it's unbalanced, right? Yeah. So to keep it balanced, I have to add the same amount to the other side so that it stays balanced. Yeah. So that's the idea behind addition property. If you add something to one side, you have to add it to the other side. Yeah. Same thing with subtraction. If I were to subtract something from one side, to keep it balanced, you have to subtract the same thing from the other. Same with multiplication, same with division. Yeah. Okay, so let's look at this addition property of equality. So this one right here says if A equals B, then A plus C equals B plus C. So in other words, if A equals B, I have to add the same thing on both sides to maintain the equality. Do you need to move up one seat? You haven't written one thing down so far. Let's go. There's some seats way up here if you're having trouble focusing. Now, with our subtraction property, if A equals B, then I would subtract the same thing from both sides to keep it balanced. Okay? Did you have a question? Did somebody have a question? Somebody said something. I didn't know if it was a question. Okay. All right. Let's look at some examples right here. So, if we're going to solve this right here, now, one of the most important goals whenever we're solving algebraic equations is the variable needs to get by itself. At some point, the variable has to be all alone. If you want to think of it like the variable is a lone wolf, wants to be all alone. So whenever we have an equation, there are two sides, right? So I want you to draw a line right here, okay? Just to help you mentally get the idea that we have the left side and we have the right side. So did you hear me, Calvin? Yeah. I said to draw a line right there. I don't think you did.
I was just filling my line.
I saw that. I need you to do this.
You need to know, Calvin.
Now, so on the x wants to be all alone. So is the x all alone at the moment?
Yeah.
No, it's not. Look at the board. Don't just color on your paper. Look at the board. So on the left side of the paper, on the left side of the equal sign, is the x all by itself? No, it has this -7 next to
I
it.
thought you meant like
Shh.
away from everything.
Okay. So our goal is to get the x all by itself, in this case on the left side. Doesn't always have to be the left side. Most of the time it's going to be, but the goal is to get the x all by itself. Okay? So to do that, I will, right now it says x minus 7. So if I want to eliminate or get rid of that, I will do the opposite of whatever property is right there right now. So this says x minus 7. So to get that across this, across the equal sign to the other side, I have to do the opposite of what's indicated. Because minus 7 and plus 7 will cancel out. So just like we talked about, to keep it balanced, if I add 7 on the left, I need to
Minus 7 left.
add 7 on the right. If I add something on one side, I have to add the same thing on the other. Okay? Now on the left side, this will cancel out.
Yup.
You bring down your equals, and then negative 6 plus 7 is going to be positive 1. Okay? So remember, like on our scale, if we're at negative 6 and we add 7, that's going to take us up to a positive 1. Okay?
Wait, so far we don't make those 6 yet.
Okay. How does this not make sense?
It does. There's 6 plus 6. I don't know. I just keep going.
Okay, so let's go over it one more time. Okay? So we have to, I'm going to draw this line to get in my head. I have the left side and the right side of the equation
Do I do it every time? Right.
until you mentally get it. Once you get it mentally, the left and right, you don't always have to do it. But I've seen over the years that it helps many students to draw that until you get it. Really? Yes, you do. At least in your head. You got to draw that. Think it that way. Okay? So, now, my goal is to get x all alone on one side. Nothing else with it. X is a loner, wants to be by himself in his mother's basement. Like, get off with my side. This is my side over here. Nobody else can be on this side. X is very selfish and self-centered and wants this side all to himself.
So basically, you're
This is my room. No one else can be in here. Just me.
Oh, you want us to leave? I can do that.
No. Jonathan. So that's our goal. So right now we have this minus 7 is with it. So to move it to the other side, I have to do the opposite of what's indicated. So this is minus 7. So the opposite of minus is plus. So, but if I add 7 on the left, I have to add 7 on the right. Okay? So over here it cancels out. And look how happy X is. He's like, so happy. Yay, I'm all by myself now. And over here, I go negative 6 plus 7 is positive 1.
Okay, I know you get paper so I can write this down and take notes. Is that okay?
That's what that is right there.
No, but like, so I can write down like what I have to do.
Sure, you can do that. All right. Now, over here, let's refocus. Over here on the right side of our paper, they want us to check our answer. So to check it, what did we figure out? X is equal to 1. So we're going to come over here. Do you see where X is? We're going to take X out and put our 1 in its place.
Oh, that makes a lot.
So 1 minus 7. Does that equal negative 6?
Yes.
What is 1 minus 7?
Negative 6.
Negative 6 equals negative 6. All right. Check. It works. All right.
Check.
Okay. All right. So let's do another one. You want to?
Let's do 6.
Yeah.
Oh, yeah, we need to do another one.
Okay. Now, first thing is we're going to draw us a line. Okay? We're going to draw us a line on that right there to separate. We got the left side and we got the right side. Where is our variable this time?
Right side.
It's on the right side this time. And what is our variable? So W is selfish, wants to be by himself. This is my side. Get out of here. Okay? Is W by himself right now? No. We've got this plus 6.5. So how do I get this over to the other side? Shh. Why do I minus it? Why do I subtract it? Because I have to do the opposite of what's right there. So if that's plus, I'm going to subtract. And if I subtract on the right side,
You have to do it on the left side.
you have to do it on the left side.
So smart.
Okay, so over here, that's going to cancel out, and that's what we want. Because what is W thinking now? Yay, I'm by myself.
Yeah, you're so happy.
And then what is 1 minus 6.5? So we're at 1, and we're going down 6.5. Now we're at negative 5.5. Okay? Any questions on that? You all taking notes on this? Okay? All right. Now, we're going to check our work. So right here where there's a W, we're going to take that out, and we're going to put our negative 5.5 in there in place of it.
Is that chicken jockey?
If I were teaching my English students, like online, I have a chicken jockey sticker that I sometimes put up on the screen. But I've had that for like a long time. The chicken jockey's been part of Minecraft for forever. All right, so what is negative 5.5 plus 6.5?
1.
It is 1. Check it. Good job.
Thank you. I did.
You guys have any questions?
No.
Stay focused and on task, all right? What?
Hang on.
Because you're so special.
Oh shoot, bro, I didn't even know we did that part.
All right. So on the second page, and I'm sorry I didn't leave very much room, I need you to do those problems real quick. All right? Can you do that for me?
Can you scoot it up a little bit so I can see that?
I'm going to walk around the room to see that you're doing your work.
Oh my gosh, number 3.
Mr. West?
Okay, so I saw several mistakes. So there is a specific pattern that we have to follow. Okay, so listen up. Listen up. So I need you to pay attention. If the fidget becomes a distraction, you can't have it anymore. Then it's no longer fulfilling its purpose. Ferdy, listen up. So on this, I want to draw my line, right? I got my left side and my right side. There's not an X in this one, but there is a different letter. What's the other letter in this?
B.
B. So B is a loner. The lone wolf wants to be all by himself on the left side. On the left side. Ferdy, you guys listen up because you missed this part. So I want to get B by itself. Is B by himself over here? No. What's next to him?
2.
So on your paper, you added the 5 over to this side. Right? Do you understand? B wants to be alone, so we got to get rid of this thing that's next to him. So all the people that did that, pay attention. So we want to subtract the 2. Okay? Listen. We want to subtract the 2 because that's going to cancel out, and B will now be so happy because he's all alone. But if I subtract 2 on the left side, I have to do that on the right side. So bring down the equal, and then negative 5 minus 2 is a negative 7. Okay? B equals negative 7. Who got B equals negative 7?
Me!
Who's learning from their mistakes?
Oh, you got
Me! It's the first thing I actually
Okay.
understand in this class.
Now, All right. So so step one, when we do this, shh, I have a lot of empty seats I can move people to. Shh. So on this one, we're going to draw a line to separate the left and right. Right, Kennedy?
Yes.
Okay. Shh. Now, Now, what do I want to get alone? What's the lone wolf in this one? The K. Is K by itself on the right side?
No, it has -3.
It has a +3. So what's the opposite of +3?
Positive.
Negative. So that's what I want to do. -3 right here and -3 right there.
Is anyone else excited for October 1st?
Okay, Calvin, move up. Kennedy?
Yes.
Class, this is not acceptable. There's too much talking. You have to stop talking. Well, I did not have 100% when I walked around the room. So there's too much talking. The only thing I'm going to do now is just start moving you to different places. So stop talking. So the 3 and the -3 cancel. That's the whole purpose of doing that, because now if you turn around again, I'm moving you to the very front. Okay, I'm giving you a chance. So this is a K. Bring down your equals, and then -3, go down 3 more, gives you -6. Who got -6 on this problem?
Wait,
Who's learning from their mistakes?
Wait, let me look at this. How did I get that wrong? How did it become 6?
Okay, you're at -3 degrees, and you go down 3 more.
Shoot my pencil.
Oh, wait. So do you minus these two? You add the. Oh, I forgot to add them together.
Okay.
I get it now.
Move up here.
I forgot to add it together.
Dude, you were talking. You can blame him all day if you want
My
to.
eraser. Yeah. It was already broken.
Just move.
Alright. That's already broken.
Okay. Now, if you did not do number 3, do it real quick.
Hi, a fraction. I hate fractions.
All right, first step, draw your line. Second step, what is the variable? What is the lone wolf in this? It's the T.
It's a big bad wolf.
Is T by himself?
No.
No. So we need to do the opposite operation. So instead of -1/4, +1/4, what does that do for us? So in algebra, get in the habit of putting a little foot on your T so that it doesn't look like a plus. So if I add 1/4 on the left, I have to add 1/4 on the right. Okay? So this actually technically gives me -2/4.
What?
I think I told somebody that it was 1. I was wrong. I apologize.
Wait, how in the world?
Because -3 plus 1 gives me -2. And that's going to reduce to -1/2. Did anybody get -1/2?
How is that?
Okay,
+1/4
so -3. It's -3/4.
I can't do the fraction ones because I don't know how to add fractions.
I think you can say -3 plus 1, though. You can do this. Okay, we need to keep going.
Good at this. I'm gonna keep getting good at this. I'm gonna put this back on. I should do this.
All right. Now, we have these similar properties. Kennedy, if you keep talking, you're going to move up. Okay, so on the multiplication and division, it's the same basic idea. If I multiply on the left, I have to multiply on the right. If I divide on the right, I have to divide on the okay. So right here, if A equals B, then A times C equals B times C. Notice that we're multiplying by C on both sides. So on this one, if A equals B, then A divided by C is equal to B divided by C. I want you to add this right here. Shh. Okay, add this right here. If I divide by C on the left, I divide by C on the right. Barty, did you get that written down? Write that down right there. Okay. So, the same two steps at the beginning, Logan, are the same. Okay? We want to divide it into the left and right. Just write on your own paper, please. We're going to divide this right there. And X is what we're trying to get alone. So what's happening right here? Is this add, subtract, multiply, or divide? Multiply. If you have a number next to a letter, that indicates multiplication. What is the opposite of multiply?
Divide.
Divide. So, pay attention. We're going to divide by 2. Why am I dividing by 2? Because X is a lone wolf, wants to be all by itself, so we have to deal with that 2. So if I divide by 2 on the left, I have to divide by 2 on the right. So on the left side, we're left with just the X, and now he's really happy. And then we bring down our equals. And what is negative 8 divided by 2? That's going to be negative 4.
I have a question.
Yes?
If the 2 is like alone with the letter, does that mean it's multiplication?
Correct.
Okay. Thank you.
Now if we check it, we're not going to use algebra tiles. We're not going to do that. All right. So 2x equals negative 8. So we're going to take out the x and put our negative 4 in its place. What is 2 times negative 4?
Negative 8.
That's right, Ruger. It's negative 8. If you say that again, I'm going to make you write it.
Ruger has a fever.
How many times?
Why does it say negative 8 equals negative 8?
So that we're checking our work.
Yeah,
Check.
Check it.
We got it. Check it out. It's correct. Okay.
Wait, what do you call like the letters? Is it like a
What happens if I say it?
Variable.
variable?
You
Okay.
have to write it.
How many times?
I don't know. How many times should I make him write chicken jockey?
15.
How about 100?
2 times.
2 times?
What?
2 times 100?
6.
Oh,
He just said it again.
No, but she was asking me.
No, I didn't ask. No.
I'm going to make you write it. Is what I'm going to do. If you were trying to trap him, were you trying to trap him?
No. She was 100%.
All right. Let's move on. Okay.
Here's how you write 7 super fast.
Since. All right. So on this one, what does this right here indicate? If I have y and then a line and then a 5. Divide. Y divided by 5. So now, same thing. I want to separate it into the left and right. Y is not by itself. It wants to be by itself. But right now, it's being divided by 5. What's the opposite of divide?
Multiply.
Multiply. So, we write that like this.
Is it a coffee?
Coffee?
It's a coffee. Kidding.
Oh, this. Yes, it is. I haven't got the paw prints yet.
My notes are
Okay.
like fire.
So if I'm going to multiply by 5, what happens is that cancels out, and now who's happy? Mr. Y.
Oh, I thought you were about to say Mr.
So what is 6 times 5?
We're gonna die.
30. Ruger, sit up and take some notes.
He doesn't feel good.
Because 6 times 5 is stop talking. Put that away.
Are you sure it's hers? I know it's hers.
Okay.
You're just embarrassing.
Shh. Are there any questions on this one?
No, sir.
Did you write that down?
Yep.
All right. Now let's check our work, even though there's no box to check your work. Let's check it anyway. So we're going to have y. The problem is y over 5 equals 6. So we're going to take the y out and put 30 in its place. What is 30 divided by 5?
6.
Are those equal?
7.
Check it. It's equal.
I was gonna say that.
Okay. All right. Hey, you can do number 4 and 5. Aren't you excited?
No.
Yes, there's plenty of time, Kennedy.
It was just what time it was.
I did too. All right, let's get it started up in here.
Let's get this party started.
Good point, though. Good idea. I like that. All right. So, let's look at number 4. So again, draw you a line. So on the left side over here,
Didn't you just talk about that one?
not on the recording. So we're going to, this is y divided by 4. So the opposite of divide is to multiply by 4, but you have to do it on both sides. So that cancels out. So now y, he's like, yay, I'm all alone. And what is negative 7 times 4? That's right, it's negative 28. Way to go, guys.
Thank you.
Are there any questions on that?
Thank you.
Who got negative 28 when you did that? Who's learning from their mistakes? Jonathan and Terry?
Thank you.
All right. Now on this one, same procedure. We're going to draw that line right there. And what's the variable? X. X wants to be the Lone Ranger. Okay? Shh. Kennedy, move up one seat. Okay. So right here on this, this is pi times x. So the opposite of times is to divide. So if I divide on the right by pi, I have to divide on the left by pi. So notice how there's 2 pi's. So guess what's going to happen?
Cancel out.
Cancels out. So what are we left with?
6.
6. Bring down your equals. Over here the pi also cancels out. So we have x equals 6. Okay, who got 6? Did anybody get 6 when you did that?
7.
Good job. Did you get 6 before I did it? That's what I mean by that question. All right. Hey, let's connect this to real life, shall we?
I'm okay. I've got gas.
All right. The temperature in a crater on Mars is 0 degrees Celsius at 1 p.m. The temperature decreases. Is decreases a positive or a negative? Negative. It decreases 8 degrees Celsius every hour. When will the temperature be negative 50 degrees Celsius? Okay? So we want to let T be the time. So the change in temperature, 0 degrees Celsius, equals the hourly change in temperature times the time in hours. So the question is, when will the temperature be negative 50 degrees?
How do you do Celsius?
That part actually doesn't matter in the way that we're setting this up. So we're going to put negative 50 over here, okay? And how much does it change per hour?
8.
Not just 8.
8 degrees. Decreases.
Negative
Negative 8. So negative 8. And then the time is right here,
10.
T. T.
That was like an L.
Look right there. What is that? Let T be the time. So our equation is negative 50 equals negative 8T. Equals negative 8T. Okay, so now we go back to all the things we've been learning. We're going to draw this line, and then to get the t by itself, I need to divide by -8. And so,
Hey, once you add my negative
no, it's times. It's a times problem. So the opposite of times is to divide. So I'm gonna use the calculator for this. So we're gonna go -50 divided by -8, and that gives me 6.25. So I'm going to go back over here, and so that's going to be 6.25 hours equals t. The time is 6.25 hours. So it will take 6.25 hours. So their question was when? When? So right now it's 1 p.m. So if I take that plus the 6.25, that's going to be what? 7:15 p.m.
Wait, how?
Yeah.
7:25.
Well, how much is 0.25 of an hour? It's 15 minutes.
Oh,
What's half an hour?
never mind.
Right? 30 minutes is half an hour. So 7:15 p.m. Put these in your binders. Great job, you kids.